This talk was organized by Farrokh Alemi, who works at George Mason University and teaches about health informatics. I am an avatar and will narrate the talk. A standard normal distribution has a mean of 0 and a standard deviation of 1. 68.27% of data fall within one standard deviation of standard normal curve, the area marked in yellow. 95.45% of the data fall within two standard deviations. This is the white and the yellow area under the standard normal curve shown here. 99.73% of data fall within 3 standard deviation of standard normal curve. Knowing how many standard deviations an observation is away from the mean tells us how likely it is to observe it. This provides an easy method of understanding how unusual an observation is. An observation becomes less frequent and more unusual depending on number of standard deviations it is away from the mean. At 1 standard deviation, 84% of observations fall below it. At 2 standard deviations, 98% of observations fall below it. At 3 standard deviations, 99% of the observations fall below it. The chances of observing a value more than 3 standard deviation away from the mean falls below 1 in 100. Standard normal tables exists that tell us how common a value is based on how many standard deviation it is away from the mean. To count the number of standard deviation an observation is away from a mean, we need the z-score. This equation shows the z-score for an observation x that follows a distribution with mean u and standard deviation sigma. While the original distribution is centered around mean u and has standard deviation of sigma, the z-scores transform the distribution to a standard normal distribution. Let us take a very simple example to demonstrate the power of normal distribution. Assume that patient ratings are normally distributed and we have 3 ratings of 3, 4, and 5. What is the mean and standard deviation? The mean is 4 and the standard deviation is 1. Given this mean and standard deviations, we can answer other questions. In this question, we are asking how unusual it is to observe a rating of 1. To answer this question, we need to calculate the z-value. The z-value is -3. We can now look up in standard normal tables to see what % of values are more than 3 standard deviation below the mean. This shows a standard normal table. The columns show the last 2 digits of the z-score. The rows show the z-score to the first digit. The cell values give the % of values falling below the z-score. Zooming in, we can select for the second digit the column corresponding with 0.00 and the row corresponding with -3.0. We read that the probability of observing a z of less than 3.0 is 0.0013, therefore observing a rating of 1 is quite rare. Standard normal distributions allow us to examine how rare it is to observe a particular sample value. This completes the presentation of standard normal distribution. I hope you found it useful.